Hello, today we're going to be doing an experiment to try to measure how much oxygen is in the atmosphere, how much oxygen is in the air. Believe it or not, air is actually a scientific term that refers to the specific mixture of gases that make up the atmosphere. All of the mixture of gases that we breathe in, that is the definition of air. Oxygen is one of those gases, and like we saw before, it's about 21% of air is made up of oxygen. And oxygen is special because of all of the things in the air: nitrogen, which is about 78%, carbon dioxide, argon, all of those gases. Of those, oxygen is the only one that is combustible. So that makes it chemically unique. It is a gas that can burn. And so we are going to today use a candle and some water and test tubes to see how does this candle use oxygen, and we use the fact that it is combustible to figure out how much oxygen there is in the atmosphere. So the first thing that I'm going to need to do is figure out how big is this test tube? What is the volume of this test tube? My goal here is going to be to see right now there's air in this test tube. I don't know the volume yet, but this is currently full of air. I'm going to, using my candle, burn up the oxygen. Oxygen is the only gas in the atmosphere, in the air, that is combustible. It is the only gas that can be burned up. So using this candle, I'm going to burn up the air in this tube and replace it with water, replace it with something else, and see how much of the air burned up. So before I can do any of that, I need to figure out the volume of this test tube. So I'm going to fill it up to the top with water. So I have a full test tube of water. I'm going to dump it into my graduated cylinder to measure the volume of this test tube, and I get a volume of 60 milliliters for my test tube. So I'm going to write that down so I remember it, that the volume of my test tube is 60 milliliters. So I know that this holds 60 milliliters. I'm going to put some water in my Petri dish here. So here on this setup, I've got just a Petri dish with a candle sticking up. I used a little bit of Play-Doh to make the candle stand. And now I'm going to light my candle. So I've got a test tube full of air, and when I flip the test tube on top of this candle, it is going to burn the oxygen that is currently in this test tube. The water in my Petri dish doesn't like that there's a vacuum in here now that the oxygen is gone, so the water is going to rise up to fill in the space left behind by the oxygen. And I want to measure how high did that water rise up. So when I put the test tube over the candle, it goes out and the water level rises. And I'm going to use a highlighter or a expo marker to mark how high that water rose to. And now I've got a mark that shows where did the water reach. I'm going to rinse this out because I don't want any smoke in it. And now I want to know just what this volume is, because remember here it was upside down. I went up to my orange line, but I can't measure just this amount using water. So instead, I'm going to turn it right side up. I'm going to measure this whole bottom volume up to my orange line and then subtract so that I can get just the top portion. So when I add some water in and measure to that orange line, now I'm going to figure out how much water that is by pouring it into my graduated cylinder. And that is 44 milliliters. So I know if the water rose 44 milliliters, the whole thing is 60. I can do 60 minus 44 to see that the top portion is 16 milliliters. So trial 1, I got a water level rose by 16 milliliters. I'm going to do it all again and see what I get this time. So I'm going to flip the test tube over the candle, measure where the water rose to, rinse this out so there's not smoke in it. Measure up to my orange line. Dump this into my graduated cylinder to see the volume up to the orange line. And this time it was 45 milliliters. Just about the same. So again, 45 is the bottom. What I really want to know is the top. So I'm going to do the whole thing, 60 minus the bottom, 45. Give me the top, which will be 15 milliliters. There we go. Measure out my last volume, same deal as before. This one a little bit lower. This one was 43 milliliters. So again, 43 was the bottom. I want the top. The whole thing is 60. 60 minus 43 gives me 17 milliliters as the top. Now I need to do some calculations. I know that in my first trial, the water rose by 16 milliliters. In my second trial, it was 15 milliliters. And in my third trial, it was 17 milliliters. I need to take that and turn it into oxygen, or a percent of oxygen. So the water rose up 16 out of 60 milliliters. 16 out of 60 in trial 1 can give me a percentage. So I'm going to do 16 divided by 60 and multiply that by 100, which gives me 26.67%. I'm going to look again at trial 2, where the water rose 15 milliliters. 15 out of 60 gives me 25%. And the last trial was 17, and 17 out of 60 gives me 28.3%. So I've got 26.7%, 25, and 28.3%. If I average all of those together, I get 26.67%. So I found across 3 good trials that the volume of oxygen was 26.67%. But I said at the beginning it was 21. There are a couple of things that can cause an error. And the first one is right in front of us, is what's happening right here. When water rises up, the candle is taking up space. So if I do this again, and again, cover and let the candle go out and the water rise. The candle is also displacing some water. The water can't be in the space where the candle is, and so the water appears to be higher or appears to have more volume because the candle is in the way. If we were able to do this without having the candle right in the middle, then we would get right about 21%. But the candle is making the water appear to go higher than it actually is going, or appear to take up more space than it is actually taking up. And so that gives us that kind of 4 or 5% error. We really, though, getting an average of 27%, 26.67, is about as good as we're going to get. Again, the actual amount is about 21%, and that candle is taking up space. So we were spot on with what we can expect this kind of experiment to give us. So there you have it. There is one way that you can experimentally measure the amount of oxygen in the air, the percent oxygen in the atmosphere, using a candle, some water, and a test tube. And it gives you a pretty good estimation for how much oxygen is in the air that we breathe. Bye.